section 3.3. Continued, we talked about the change of base formula, but now we're going to start talking about the properties of logarithms. All right, properties of logarithms. Say this, if you have the log of any base number of two things multiplied, that is equivalent to having saying that it's the log of some base number of the first letter or the first whatever it is that you're taking the logarithm of, plus log base A of the second one. So log base A of two things multiplied is equivalent to log base A of the first one plus log base A of the second one. And I, in parentheses after it, showed it to you guys with the natural logarithm too.
I can't read.
ln, which just says number 1.
Oh.
Number 1, ln of uv equals ln of u plus ln of v. I don't even know that you necessarily need to write these three down. They're exactly the same as just the common logarithm, so it might not be necessary to write the ln's down, but I put them there in case you want to. They work exactly the same way if it's log of some base number or if it's the ln. Remember what ln means? Natural logarithm, but it represents the logarithm with what base value? E. Log base E. Yep. All right, log base A of two things divided. So we have a U divided by a V. That's the same thing as taking log base A of U minus log base A of V. Same thing happens if you're talking about the natural logarithm. Natural logarithm of u divided by v is the same thing as having the natural logarithm u minus natural logarithm of v. Now, you just have to remember that if you're multiplying, these things are exactly the same. The only difference between them is that if you are multiplying, you put a plus sign in between them. If you are dividing, you throw a minus sign in between them. And then one more pretty popular property of a logarithm. If you have log base A of some value put to a power, that is equivalent to taking that power and throwing it in front of the logarithm. So log base A of something to a power is the same thing as putting the power in front of your logarithm. So it would be, in this case, n times the log base A of u. Can I scroll?
Not yet.
Okay, no. Sorry.
True. I'm almost done. All right.
All right, are we ready?
Yeah.
All right, examples. All I have left are some examples for you, and then I'm going to have some for you guys to try. Yay! That reminds me, yesterday I said to my son, he was complaining because I made him do a, do you guys know what a Mad Minute is? Did you have to do Mad Minute? Yeah. He's supposed to do a Mad Minute every Tuesday and every Thursday. His teacher says every Tuesday, every Thursday you need to do a Mad Minute. So yesterday was Thursday, so I made him do a Mad Minute, and he gets so mad at me when I make him do it. But he said to me, when he started complaining, I'm like, yay, math! And he's so mad at me. It made him more mad that I said, yay, math. Why do you always say that?
Could you do that again?
Well, I'm not kidding though. That's really what he said.
I'm
He
just
was
gonna have to
so
go
mad
watch
at me.
because you're recording it. So watch the video.
Well, good thing you can't see my face in it. So, all right.
I still know what it looked like.
In terms of
Wait, I didn't see it.
ln of 2 and ln of 4.
Yes,
All right, so we need to change ln of 8 in terms. We need to write ln of 8 in terms of ln of 2 and ln of 4. So think about the properties that we just talked about. What is 8 the same thing as saying?
2 times 4.
2 times 4. So you could rewrite ln of 8 as the ln of 2 times 4. You okay with that?
Yeah.
I asked you to write these things in terms of the ln of 2 and the ln of 4, but right now it doesn't say ln of 2 and ln of 4, it says ln of 2 times 4. So what could I do to this now?
That's
That thing. Could you be a little bit more specific?
Property one.
distribute ln.
No, you can't. Oh yeah, I guess you are. You are kind of like distributing, but what goes in between the two ln's then?
Plus.
A plus sign, yeah. So ln of 2 times 4 is the same thing as writing the ln of 2 plus the ln of 4.
Sweet.
All right, ln of 2 divided by 64. Well, let's apply the property to it first of all. When you have two things divided, that's the same thing as saying that it is the ln of 2. Back at your properties, ln of 2 what?
Minus the.
Minus the ln of, in this case, 64. But I asked you to write it in terms of the ln of 2 and the ln of 4. So what am I going to do? Yeah, I can write 64 as 4 to the 3rd power. So this is equivalent to the ln of 2 minus the ln of 64 is also known as 4 to the 3rd power. 4 times 4 times 4 is 64. But right now it is not written really as the ln of 4, it's written as the ln of 4 cubed. So what can I do to this? Now. Where do I put the 3? Yeah, you put it in front of the ln. So you could rewrite this as the ln of 2 minus, that goes in front, 3 ln of 4. Yes? Some more examples here of just moving things around, switching them around, using all the properties that we just talked about above. So, can I scroll? Are you guys okay with this? First thing that we're going to do is change log base 5 of 4x to the 6th power y squared using our properties of logarithms. So, log base 5 of 4 times x squared times y squared. They're all being multiplied. So when they're being multiplied, what do? Separate them all, and what do you throw in between them all?
Plus.
Plus sign. So log base 5 of 4 times x to the 6th power y squared is the same thing as log base 5 of 4 plus log base 5 of x to the 6th power plus log base 5 of y squared. Seems like an easy enough concept, doesn't it?
Yeah.
Yes.
It seems like we're going backwards instead of.
Well, there will be a time when I might give you this and ask you to come up with that. You have to be able to go both ways. What do I do now with the 6 and the 2?
You add them.
Slap in front of the log.
You throw them in front.
Oh.
Throw them in front of the logarithm. So this is the same thing as log base 5 of 4 plus, you throw that 6 in front, 6 log base 5 of x plus 2 log base 5 of y. The directions say to expand it, so we're making what was short long. I might have you go the opposite way. I will give you the expanded form and ask you to write it in the condensed form. You okay with this? Anything? You guys are silent? Silence is good, maybe?
It's
do two.
All right, let's do number 2. It's a natural logarithm, so leave it as a natural logarithm. We're dividing. When you divide, that means that you are going to separate them and subtract. Very nice. So this is the same thing as, by the way, I'm going to rewrite this. This is, actually, I guess you don't have to, but what does the square root of 4x minus 7 mean? What does the square root mean? I feel like this has come up a couple of times recently. The square root is the same thing. If you have the square root of x, that was the same thing as having x to what power? Not -1.
1. Oh, 0.
Can you do that message now? X to the 1/2 power?
No.
Nope.
No.
If you have, I guess it has. I know this has.
No, it
What if
has.
you have the cubed root of x?
So
You have the cubed root of x. That was the same thing as x to the 1/3
common
power. I'm
sense
pretty
now,
sure
though.
we talked about
No.
this. The square root of x, is the same thing as having a little 2. When you have a square root, there's an understood 2 out in front of your radical. Not really out in front, it's actually inside your radical here. So if you have the square root of x, that x is actually put to the first power. So when you are changing any kind of a radical to a fractional exponent, it's always this number, the power, divided by whatever root it is you're taking. So the square root of x is the same thing as x to the 1/2 power. The cubed root of x is the same thing as x to the 1 divided by 3 power. What if you have the 4th root of x, you guys?
You have a 4.
It would be x to the 1/4 power. Let me throw a curve at you. What if you have the cubed root of x squared? What's the cubed root of x squared as a fractional exponent?
X.
X to the 2/3.
X to the 2/3 power. Very nice. So in other words, it's this divided by whatever root it is you're taking.
Okay,
X
so
to
is that
2/3
one
power.
4x
So-
minus 7 to the 1/2?
Yeah, so this is the same thing as 4x minus 7 to the 1/2 power minus, because it's dividing, minus what? The ln of 10. Okay, we're not done yet though. Why am I not done?
You still
You gotta
have
have the 1/2 in front of the ln.
Yeah, I still have that 1/2 power that can be moved in front of the ln. So I could rewrite this then as 1/2 ln of 4x minus 7 minus the ln of 10. All right, the next example is asking you to condense it. So we're going to work backwards. We're going to make it smaller. We're going to make what it is long smaller. So start writing this example down.
Does that say divided by, like the first one?
These are, this is a plus sign
Oh, alright.
and a plus sign.
Okay.
Yep.
Miss Corrigan, what's the base? Oh, it's gonna be 10.
What's the base, did you say?
Yeah.
Well, if there isn't a base there, then it is
10.
base 10. Yeah. All right. We have 1/5 log x plus 3 log 2 plus log x minus 3. So there's plus signs in between everything. So what does that mean? You're actually taking the log of what? Yeah, things being multiplied. So, and then we also have this number out front. We have a 1/5 in front of that log of x. What am I going to do with that 1/5?
Put it as a new.
Put it as a power. Move it up here to the power. What about the 3?
Same thing.
Same thing. Take this 3, move it up here as a power. So I'm gonna probably rewrite this first of all like that. So we have log of x to the 1/5 power. By the way, that should look vaguely familiar to you guys. Log of x to the 1/5 power. Yes.
Does that mean that if you did the little square root thing, there would be a little 5?
Yes. It wouldn't actually be a square root though. It would just
It'd
be
be a fifth
a fifth root. But yeah, it would be the square root symbol, which really is called a radical symbol. But if you're talking specifically about it being a square root, then there's a little 2 in front.
Would it be a little quint?
A quint.
Fifth root.
A quint root, yes. No, it's a fifth root. You call it a fifth root. All right, this is log of 2 to the 3rd power. And then, of course, we still have log of x minus 3. All right, and then we need to clean this up a little bit. They're all being added, so I can make it one thing.
Ooh.
So this is the same thing as having the log of a bunch of things multiplied. But at the same time that I'm going to multiply these things, I'm also going to clean it up a little bit. What, again, is x to the 1/5 power? The 5th root of x. I'm going to put a little 5 out here. I'm taking the 5th root of x. Times, what is 2 to the 3rd power?
Ooh. 8.
It's 8. So the 5th root of x times 8 times
X minus. Ooh.
x minus 3. That is an acceptable answer. I would say the only thing that probably would make this a little bit nicer is if you kind of wrote it in a better order. Usually the constant number would be in front, and then maybe the 5th root of x in the middle, and then x minus 3. So I guess if you wrote this a little bit nicer, it would be the log of 8 5th roots of x times x minus 3. And I guess too, you could, if you wanted to, you could distribute the 8 into the x minus 3 to get you 8x minus 24, but this is acceptable. If you wanted to take an extra step, you could. Number 2, you have 2 ln of x minus 5 minus the ln of 4 plus the ln of 2. All natural logs, leave them in natural logs. But the problem here is that we are subtracting those, and then we are adding that last one. So we have a combination of things being divided and then being multiplied. And according to PEMDAS, please excuse my dear Aunt Sally, you multiply and divide from left to right. So in this case, you will end up multiplying x minus 5 times the 4 and then dividing by 2 if you follow the correct order.
You mean follow?
What'd you say?
Something.
Do you have a different acronym?
No. I'll tell you later.
Oh, did I say foul?
Yes.
Follow.
Back in the video.
Alright, so we have a 2 out front. I move it to a power. Looks like that's the only thing I can do in terms of powers. So I'm going to rewrite this as the ln of x minus 5 to the 2nd power minus the ln of 4 plus the ln of 2. Alright, now these two things, the x minus 5 squared and the 4, have to be divided. So we have the ln of x minus 5 squared divided by 4, and then that has to be multiplied by the last number, which is 2. So if you can just ignore the fact for a minute that we are talking about the natural logarithm of this, simplify this. This 2 right here times 2 really means 2 over 1. So I have a 2 on the top of this fraction, and I have a 4 on the bottom of that fraction. 2 over 4 will reduce to 1 over 2. So I could rewrite this then as the ln of x minus 5 squared over 2. Are you okay with the math that I just did that?
Yep.
Just did that. I reduced the 2 over 4 to 1 over 2. So So I have x minus 5 times 1. I didn't put the times 1 there, it's not necessary. And then I have 2 times 1 on the bottom. We have the ln of x minus 5 squared over 2. If you wanted to, you could FOIL the x minus 5 squared, but you can leave it like that too. Is that what you were going to ask me?
I was gonna ask where you got the example from.
Where did I get the examples? I don't remember. I don't think I Googled them. They're probably in your textbook, or there's similar ones in your textbook. Alright, number 3. This might be the last example, I'm not sure. It is the last example.
Alright.
1/3 log base 3 of x plus log base 3 of x
That
minus
says
6.
1/2.
Did I say 1/3?
Yes.
Yeah.
Hey, 1/3. I think I was looking at those bases. So we have 1/2 power. All right. This 1/2, because it's outside of the parentheses, really means that each one of the, in other words, if I distributed a 1/2 into the parentheses, what I would really have here is 1/2 log base 3 of x plus 1/2 log base 3 of x minus 6.
What's at the end? Is that a z? Oh. Alright. Okay.
That's a Z.
I'm being serious.
But why would there be a z there?
You tell me.
You were one
I thought
about
it was a
him
Z
or
too.
about
No, I
me?
was wondering about the.
The z.
The
Yeah.
Oh, the what?
It looks like a Z.
It looks like a z.
Okay, let's keep going here. All right, so this 1/2 out front can be put to the powers. So I'm going to rewrite this as log base 3 of x to the 1/2 power plus log base 3 of x minus 6 to the 1/2 power. These two things, because of the plus sign in between them, what does it mean about x to the 1/2 power and x minus 6 to the 1/2 power? It means you're multiplying, yes. So I'm going to rewrite this as a single logarithm, log base 3 of x to the 1/2 power times x minus 6 to the 1/2 power. Both of these things are being put to the 1/2 power. And after our recent conversation, what does 1/2 power mean? It means the square root. Yeah. So what I'm going to do here is change this so that it is log base 3 of x times x minus 6 to the square root of x times x minus 6. And if you wanted to, you could distribute the x. So you get x squared minus 6